Okay, everyone. We are. People are rearranging. We're starting, and a few details. Okay. Okay. Got it. Okay. Can I go? Yeah. Okay. So, as I said, this is in person, obviously, and then we're doing this virtually. All of the guests that are joining the workshop online will have their microphones muted and video disabled. And for those of you online that are listening to this, you will have the opportunity to ask questions via the chat window, as well as raising the hand. Questions posted in the chat will be answered by a member of the Science Advisory Panel, which I will introduce briefly, unless it is determined that the question would be better addressed during the question and answer session at the end of these presentations. To ask a question in the question and answer session, please use the hand raise button that can be found in your Zoom toolbar. Once you raise your hand, you will be placed in the online questions queue in the order in which you raised your hand. You will see a prompt that will ask you to unmute your microphone. Follow the prompts to enable your question to be answered. The moderator will mute your microphone thereafter and lower your hand in the queue. If you have another question during the session, simply raise your hand again and you will be added back into the queue. Okay. So to start, okay, listed here is the agenda. And there will be a total of 4 presentations and a general discussion. I'll give the brief introduction. Dr. Rachel Smith will give the presentation on the performance of the San Dieguito Wetlands Restoration Project. Dr. Kat Beheshti will discuss salt marsh vegetation and habitat areas and give us a status update. And finally, Dr. Mark Page will discuss fish and invertebrate standards. And then again, followed by a general discussion. Okay, so this is the introductory talk. And I just want to briefly introduce you to the personnel on the project. There are a total of 6 project scientists. Mark Page, who's here and who's going to be talking, and Dan Reed are up at UCSB. I'm at our office in Carlsbad, and doctors Kat Beheshti and Rachel Smith are also down here in the Carlsbad remote lab. And we also have work with Dr. Mark Steele at Cal State Northridge, who was responsible for developing the protocols for studying the abundance and diversity of wetland fish. We also have a extensive and talented scientific staff, most of whom are down here. We have 2 folks that are up at UCSB. And then in addition and in attendance today is our Science Advisory Panel. And it is made up of Professors Rich Ambrose from UCLA, Pete Ramonde from UC Santa Cruz, and Russ Schmidt from UCSB. Okay, so some background's important for understanding the purpose and rationale of the SONGS mitigation project. SONGS is a San Onofre nuclear generating station. When operation was cooled by a single pass seawater system. The 2 units, 2 and 3, have separate intake lines that are located in about 30 feet of water offshore of the power plant. And the water that is taken in is heated to about 19 degrees Fahrenheit above ambient, and it produces turbulence. And this heating and turbulence results in the killing of all fish eggs, larvae, and small immature fish that are taken into the intake system. The SONGS operation was projected to cause substantial reductions in populations of adult nearshore fish within Southern California, within the Southern California Bight. The California Coastal Act requires mitigation of impacts to the marine environment. And the California Coastal Commission is responsible for implementing the Coastal Act. As a mitigation for the impacts to these larval, juvenile, and fish eggs caused by songs, the California Coastal Commission required Southern California Edison to create or substantially restore a minimum of 150 acres of wetlands, excluding buffer zones and upland transition areas. And it also required SCE to provide funding for the scientific oversight and monitoring of the restoration project that is independent of Southern California Edison. This slide summarizes the key elements of the SONG's wetland mitigation project. Again, as I said, it's out-of-kind compensation for in-plant losses of larval and juvenile fish caused by the operation of SONG's units 2 and 3. In order to do this, physical and biological standards were established to evaluate the performance of the wetland restoration project. 1 year of mitigation credit is given for each year that the San Dieguito Wetlands Restoration Project meets these performance standards. And fulfillment of the SONG's wetland mitigation requirement will occur when the number of years of mitigation credit accrued by the San Dieguito Wetlands Restoration Project equals the 32 total years of operations of the SONG's units 2 and 3. Okay, this is this map shows the location of SONG's, the red triangle, the San Dieguito Lagoon, the green square, and 3 reference wetlands shown with the white dots that are used to evaluate the mitigation standards for San Dieguito. And the 3 wetlands are Carpinteria Salt Marsh and Magoo Lagoon to the north, and the Tijuana Estuary to the south. Okay, this is an aerial photograph that shows San Dieguito wetlands before restoration and grading. And so you can see the I-5 freeway going through it and the San Dieguito River. And before the excavation and grading, the habitat consisted of ruderal or weedy fields, old ag fields. You can actually see some of the fields, cultivated, and an old airfield, a World War II dirigible airfield to the west of the freeway. This is an aerial photograph that was taken in 2016, and it shows the post-grading. It shows intertidal habitats. It shows a substantial subtidal basin to the west of the freeway. And it also includes nesting sites for the California lease turn, which we do not monitor. It's a separate permit. And then disposal sites. And the disposal sites, this is important because about 2.3 million cubic yards of material was excavated to create this tidal wetland, and all of it was disposed of on site. Okay, this shows a timeline for the project. And so you have a schematic on the upper right, and then a picture on the lower right. And so construction for the project started in 2006. Essentially all of the modules, construction of all the modules was completed in 2010. There was an additional about an acre of wetland that was created at what was called Grand Avenue in 2011. And in 2014, the area called the W23 west of the freeway was regraded. And there has been extensive planting starting in 2008, 2009, 2011, and 2016, and most recently in 2022. One of the features of this restoration is that it has to have a continuously open inlet. And so prior to the beginning of monitoring, There was a large inlet dredging that cleared out the inlet. And then subsequently in November, December of 2015, 2017, 2019, and most recently in 2022, there has been inlet maintenance. And performance monitoring began in 2012. And what we'll be reporting on today is the 11 years of performance monitoring. Come on, baby. Okay, so after the construction was completed, the inlet opened, monitoring of the wetland performance began. Annual monitoring is required to evaluate the physical and biological standards of performance provided in the SONGS permit. This monitoring tracks ecosystem development and identifies adaptive management opportunities pertaining to physical and biological functionings of the wetland. Independent monitoring is conducted by scientists from UCSB with advice from our science advisory panel, and all of our scientific staff are in the back row, and they're great staff and they do a great job. The restored wetland is currently providing habitat for invertebrates, fish, birds, and plants. And here are a few: fiddler crabs, California halibut, willowbit, godwit, and a variety of wetland plants. I'm bringing your attention to our mitigation website shown here. This can be found at the URL listed above, and it contains a lot of useful information about the history of the SONGS coastal impacts, the rationale requirement for SONGS mitigation, and a description and status of both the wetland and the artificial reef, which is another part of the total mitigation for the SONGS effects. And very importantly, all of the project's monitoring data are being made publicly available through a data portal with the U.S. National Science Foundation's Environmental Data Initiative. So you'll be able to access that data. And this can be accessed on the SONGS website, okay? And then the website has a library of project-related documents that includes workshop presentations. And today's workshop is being recorded. The reef workshop that was done last month was also recorded. Annual reports, construction reports, and various regulatory documents. The library can be browsed by year, project type, author, and type of document to assist users in finding what they're looking for. Lastly, on the homepage of the website, you can subscribe to our mailing list and follow us on Instagram or contact us by phone or email. Okay, so that concludes the introductory talk. And next I'm going to turn it over to Dr. Rachel Smith, who's going to talk about the performance of the San Dieguito Wetlands Restoration Project. Okay.
Great. Thank you, Steve.
Forward back.
Okay, perfect. Hi, everyone. Thanks for being here. And I'm excited to talk to you about the performance of the San Dieguito Wetlands Restoration Project. And this presentation will report on the results of our 11th year of performance monitoring of the San Dieguito Wetland Restoration Project and our evaluation of its progress towards meeting the performance standards that are required for successful mitigation. And so first, I'm going to begin by defining the different performance standards that we use to evaluate the restored wetland. And so first, we have absolute standards that are measured only within San Dieguito wetlands. And so, for example, that might be that the area of restored wetland habitat shall not vary by more than 10%. Then we also have relative standards that are measured both at San Dieguito and then against natural wetlands that serve as reference sites. And so this could be, for example, the density of birds shall be similar to that of natural wetlands in the region. And so I'm going to begin by focusing on these absolute standards. And so the San Dieguito Wetlands Restoration must meet each absolute performance standard for that year to count towards mitigation credit. And the evaluation of each absolute performance standard is based on the value for the current year. And so there are 5 absolute performance standards that include tidal prism, habitat areas, topography, plant reproduction, and exotic species. And I'm going to quickly define what each of these are in terms of their requirements. And so tidal prism is the volume of water that's exchanged in an estuary between the low and high tide levels. And it's a metric of tidal flushing, marsh inundation, and inlet stability. And so this standard specifies that the tidal inlet or the tidal prism of San Dieguito Wetlands shall be maintained. And then next we have the habitat area standard, which specifies that wetland habitats will not vary by more than 10% from that which is in the final restoration plan in terms of planned habitat areas. The next standard is topography standard, which specifies that the wetland will not undergo major topographic degradation, such as excessive sedimentation or excessive erosion. And then plant reproduction specifies that there's certain salt marsh plant species that must demonstrate reproduction at least once every 3 years. And then lastly, the exotic species standard requires that the important functions of the wetland shall not be impaired by exotic species that could negatively impact wetland functioning. So for example, by altering food webs or the habitat structure. And so this slide is summarizing whether each of these absolute standards was met during each of the last 10 years. And so here a green circle represents that the standard was met for a particular year, whereas a red circle indicates that the standard was not met for that year. And so you can see that San Dieguito has met 4 out of the 5 absolute performance standards for the last 10 years, which includes tidal prism, topography, plant reproduction, and exotic species. However, San Dieguito has not yet met the habitat area's absolute standard. And so we're going to take a closer look at the results of this standard. And so as I mentioned before, this standard states that the area of different habitats shall not vary by more than 10% from the areas that are indicated in the final restoration plan. And this performance standard was really designed to preserve the mix of habitats that was provided in the final restoration plan and really guard against large-scale conversions from one habitat type for another. So no shifts between large-scale shifts between vegetation to mudflat or vice versa. And so the left side of the slide shows the habitat plan locations for salt marsh, mudflat, and subtidal. So salt marsh in green, mudflat in brown, and subtidal in blue that were in the final restoration plan, as well as their associated planned acreages. And so now I'm going to walk through the different classifications of what determines whether habitat is classified into different categories, beginning with subtidal habitat and then moving up in tidal elevation. And so we classify habitat as subtidal if it is continuously submerged, like you can see in this photo. We then classify habitat as mudflat habitat if it is intertidal and located at less than 3.5 feet NGVD, and also have less than 5% cover of vegetation. So if we look at this photo on the bottom right, we see that the unvegetated area on the left would be classified as mudflat habitat because it's within that lower elevation range, whereas the unvegetated area on the right is too high to be classified as mudflat. And then we classify habitat as salt marsh if it is intertidal and located at less than or equal to 4.5 feet NGVD. And also if it has at least 30% cover of vegetation, which is something we evaluate using 10 by 10 meter grids and aerial imagery. And so in addition to the habitat area standard, which is an absolute standard, there's also a relative standard for vegetation cover, which we'll go into more detail later. And then lastly, we have an other habitat category, which is not a planned habitat type, and that is not included in the final restoration plan. And this category was actually defined after monitoring began, and it includes areas that are intertidal and less than or equal to 4.5 feet NGVD with less than 30% cover of vegetation. And so if you look at this photo in the bottom right-hand corner, you can see that there was not enough cover in this area to be classified as salt marsh, but there was too much cover and it was located too high for it to be classified as mudflat and therefore other habitat. And so this figure shows the planned acreages for subtidal, mudflat, and salt marsh habitat in the white bars, with the red lines representing plus or minus 10% of the planned habitat areas. And now if we add the results from the 2022 survey in black bars, you can see that although the subtidal habitat was within this designed area, both mudflat and salt marsh fell short of the designed minimum values for the plan. And so for mudflat, we had 16 acres of habitat in 2022, which falls 6.4 acres short of the 22.4 acre minimum design requirement. And for salt marsh habitat, we had 82.3 acres of salt marsh habitat, and that falls just 1 acre short of the design target. And so as a result, this performance standard for habitat areas was not met in 2022. And so if we look at the trend in habitat acres over time, we can see that salt marsh acreage is on a really promising trajectory, and we're really only 1 acre short of this minimum requirement for 2022. And I'd like to point out this pronounced increase in habitat between 2018 and 2019, which was likely due to heavy rains during that period. And that really facilitated the growth of salt marsh plants. And so we're really hopeful that with the recent rains we've had this year, that will be a promising sign for vegetation in 2023. And hopefully we can make up that 1 acre. In contrast, we see the acreage of mudflat has been decreasing, and in particularly in the last 4 years. And we're currently, as we mentioned before, 6.4 acres short of that design target. If we look at subtidal habitat in the bottom left corner, we can see that the area has been within the 10% of the design target for 2022, and that has been relatively consistent over time, except for in 2015, when we saw an increase in subtidal acreage, which was a consequence of a warm water event known as the Blob or an El Nino event that led to elevated sea levels in that year that therefore increased the acreage of subtidal habitat for that year. And then another promising sign is in the bottom right-hand corner, a figure of other, which again is not a planned habitat type, but we see an overall decline in this category over time. So that's great to see. And so now moving on from our absolute standards to focus on the relative standards. Again, these are standards that we measure at San Dieguito and also against natural wetlands that serve as reference sites. And the evaluation of relative standard in any given year is based on an average calculated from the data collected at San Dieguito Wetlands and the reference wetlands for that year and for the previous 3 years. So that's in contrast to the absolute standards where we calculate just for the current year. And in assessing the performance of the San Dieguito Wetlands Restoration Project, we defined similar as when the 4-year running average for a relative performance standard at San Dieguito Wetlands is equal to or better than that standard for the lowest performing reference wetland for that standard. And so overall, to be successful, the San Dieguito Wetlands Restoration must provide resource values that are similar to those of natural wetlands in the region. And we use a running average rather than a value just for the current year to help better account for natural fluctuations over time. And so the criteria for including a wetland as a reference site is specified in the SONGS permit, and the permit requires that reference wetlands be relatively undisturbed, tidal, and located in the Southern California Bight. And so we assessed 46 potential sites as reference sites, and we found that Carpinteria Salt Marsh, Magoo Lagoon, and Tijuana Estuary best met these criteria. And so here's a list of the 15 relative performance standards that we measure. And so the first one that we look at is a physical standard of water quality. Then we have 10 standards that are related to biological communities, and these include density and species richness of birds, fish, and invertebrates. And then for fish and invertebrates, we also measure these in both main channel habitats and tidal creek habitats. And then we have 3 relative standards that are related to vegetation and algae. And lastly, we have 1 standard that's related to food chain support, which we measure by the density of feeding birds. And so this slide summarizes whether each relative performance standard was met over time. And so a green dot indicates that the standard was met for that particular year, and a red dot indicates that standard was not met for that year. And so we're going to walk through each of these relative performance standards, beginning with water quality. And that's a standard that we assess using dissolved oxygen concentrations, and we assess the mean number of hours of continuous hypoxia, which we define as dissolved oxygen values that are less than 3 milligrams per liter. And so you can see from this plot that in every year, San Dieguito has met the standard, including in 2022. And now we're going to move on to those performance standards for biological communities, which again includes standards for the densities and richness of birds, fish, and invertebrates. And you can see that in 2022, San Dieguito did not pass for 4 of these standards, which is an improvement over the last 2 years. And so the four standards that were failed were fish density in main channel habitats, fish density in tidal creek habitats, invertebrate density in main channel habitats, and invertebrate density in tidal creek habitats. And so we're going to go into more detail about these four standards that did not pass in 2022, beginning with fish density in main channel habitat. And so I'm going to orient you to the following plots because many of the upcoming slides are set up in the same general way. And so on the left-hand side, we have the annual averages for each of the response variables for the four reference habitats. So we have Carpinteria, or not reference habits, the four wetlands. So we have Carpinteria by the blue squares. We have Magoo Lagoon with the upside down red triangles. We have Tijuana Estuary with the yellow diamonds, and then San Dieguito Lagoon with the upward facing green triangles. And then the panel on the right-hand side represents the 4-year running averages for these four wetlands. And then on the table on the far side represents the pass-fail outcomes for 2022. And so you can see, looking at the 4-year running average for fish density in main channel habitat, that there's been a decline in the running averages from 2016 to 2020. And we do see that there has been a slight improvement in fish density in main channel habitat within the last 2 years. However, overall in 2022, the 4-year running average was slightly less than the lowest performing reference wetland, which was Magoo Lagoon, and therefore the standard was not met in 2022. So now we're moving on to fish density in tidal creeks. And San Dieguito Wetlands has intermittently met this standard over the last 10 years. And there's been a general decline in the running averages for fish density in tidal creeks over time. And so since the 4-year running average for San Dieguito in 2022 was again below the lowest performing wetland, which was Magoo Lagoon in this year, the standard was not met for 2022. So now we're looking at invertebrate density for main channel habitats. And the annual value in the San Dieguito wetland has been generally lower than the value in the lowest performing wetland over time. And that carries over into the 4-year running average, where you can see that San Dieguito wetland has been generally lower than the references over time. Although it is interesting that all of the wetlands have shown a general increase in invertebrate density in main channel habitats beginning in 2018. However, in 2022, again, San Dieguito was below the lowest performing wetland, which was Tijuana Estuary, and so therefore it did not meet the standard in 2022. And then lastly, looking at invertebrate density in tidal creeks, at the annual average on the left, we see that the annual values for San Dieguito wetland have generally been well below the reference sites, and this also carries over when we look at the 4-year running average. And so again, in 2022, invertebrate density at San Dieguito was below the lowest performing reference reef, which was Tijuana Estuary, and therefore it did not pass the standard in 2022. And Mark will speak in more detail later about the potential reasons for the underperformance of fish and invertebrate densities in a later talk. So now we're going to move to the 3 relative standards that are about vegetation and algae. And so we can see that San Dieguito did not meet the standard for vegetation cover, but it has met the standards for algal cover and Sportina canopy architecture since monitoring began. And so we're going to go into a little more detail about vegetation cover results. And so the vegetation cover standard includes salt marsh vegetation cover that's greater than 30%. And so you can see that vegetation cover has generally increased over time, although in the last 4 years, since 2019, there's been little change in the vegetation cover. And this translates over to the 4-year running average, where again, we see a general increase in the running average over time, but cover is not yet filled into the point that is matching that of the reference wetlands, and therefore San Dieguito did not pass the standard in 2022. And Kat will talk in more detail about how vegetation cover is shifting over time in the wetland in our next talk. And then to look at the last relative performance standard for food chain support, which again is measured by the density of feeding birds. This standard was met in 2015 and 2016, but it has not been met in the last 6 years, including in 2022. And so across all years, food chain support has been consistently highest at Magoo Lagoon. And at San Dieguito, the running average for the density of feeding birds has declined since 2016 below the lowest performing wetland, including in 2022, where it is below the lowest performing wetland, which is Carpinteria salt marsh, and therefore it did not pass the standard in 2022. And so to review the overall requirements for relative performance standards, the San Dieguito Wetlands restoration must meet the same proportion of relative standards as the lowest performing reference wetland in a given year for that year to count towards mitigation credit. And so San Dieguito Wetlands and the reference wetlands are evaluated with respect to whether or not they meet each relative performance standard. And then we calculate the proportion of relative standards that are met by each wetland and we compare them. And so this requirement really achieves the desired mitigation goal that San Dieguito be similar to the natural wetlands without requiring the restoration to outperform the reference wetlands. And so this is a slide that summarizes the outcomes for each relative performance standard for each wetland in 2022. And so in this case, a green dot represents that wetland is similar to the other wetlands, whereas a red dot indicates that wetland is not similar to the other wetlands. And so we can see if we look at Magoo and Carpinteria that each one of these failed one standard. So Carpinteria did not pass bird density, whereas Magoo Lagoon did not pass for algal cover. And so both of these wetlands met 93% of the relative performance standards. And then if we look at Tijuana estuary, this wetland failed for the performance standards, including for water quality, species richness in main channel, invertebrate richness in main channel, and Spartina canopy architecture. And so overall, they passed 73% of the relative standards. And then as we've gone through in detail with San Dieguito, they failed 6 of the standards in 2022, which means that they've passed 60% of those standards in 2022. And so because the proportion of standards met by San Dieguito was below that of the reference wetlands, it did not meet the overall relative standard requirement for 2022. And so now to look at how those outcomes translate to our mitigation credit. In order to receive mitigation credit for a given year, the wetland restoration project must meet all of the absolute standards and then as many of the relative standards as the lowest performing reference wetland. And so far, the wetland has yet to meet the relative performance standard requirement due to a slow rate of vegetation growth and also to low densities of invertebrate in fish and invertebrates in main channel and tidal creek habitat. And then in terms of the absolute performance standards, San Dieguito Wetlands has yet to meet the habitat area's absolute performance standard due to slow vegetation growth and also loss of mudflat habitat. And so therefore, the project has not yet satisfied the performance success criteria that are detailed in the SONGS permit and has not yet received mitigation credit. And so just to review the overall performance of San Dieguito with respect to the relative standards over time, there has been a decline in the proportion of standards met in San Dieguito wetlands relative to the reference wetlands since 2017. However, we have seen an increase in the proportion of standards that are passed in 2022. So that is very promising. And there is language in the SONGS permit about the responsibility of the permittee to meet those performance standards and prescription of remedial measures should those standards not be met. And so we're currently evaluating why the wetland is not meeting certain performance standards and in order to inform potential remediation options if those are necessary. And so the following talks by Dr. Kat Beheshti and Mark Page will provide more detail about our efforts to understand why the wetland is not meeting those performance standards. And so I'm going to pass things along to Kat, who's going to give an update on our ongoing investigations that are aimed at better understanding the underperformance of salt marsh vegetation habitat areas at San Dieguito. Thanks.
Thanks, Rachel. Okay, so like Rachel mentioned, this talk is providing a status update on the salt marsh cover and habitat area standards. And we're going to end with an overview of the ongoing and future investigations aimed at better understanding the underperformance of these standards. Okay, so as a review, there are 2 performance standards that pertain to this cover, salt marsh, and habitat areas. The first is the absolute performance standard related to habitat areas that states that The area of different habitats shall not vary by more than 10% from the areas indicated in the final restoration plan. This is a standard that's only evaluated at San Dieguito Wetlands. And for the case of salt marsh, the way that we evaluate this standard is we use aerial imagery that's analyzed at 10 by 10 meter grids. And each of those 10 by 10 meter grids must have vegetation cover that's at least 30% or greater. And so the other standard that we have related to vegetation is our relative standard that Rachel discussed on vegetation cover. And this standard states that the proportion of total vegetation cover in the marsh be similar to those proportions found in the reference sites. And this standard is only evaluated in habitat that's classified as salt marsh. So it must have at least 30% cover to be evaluated for this standard. And so to review, San Dieguito Wetlands has consistently underperformed with respect to these two standards. So wait, no, I need to go this way. Wait. There, oh, cool. Okay, so Dave has this fancy doodad. Okay, so you can see for habitat areas, we have yet to meet this standard. And for vegetation cover, the same applies. The reason that these unfilled circles are here from 2012 to 2014 is because 2015 is the first year that we have a 4-year running average to evaluate this standard, like Rachel discussed for the relative performance standards. So this slide provides an overview of the changes in acres of salt marsh habitat over time. So on the y-axis here, I really like this. On the y-axis, we have acres, and on the x-axis, we have year. From 2012, which was the first year of performance monitoring, until 2022. And like Rachel mentioned during her talk, we're about 1 acre short of meeting the minimum required acres, which is 83.3 acres, or 10% of the required 92.6, which is indicated by the red line there. And then the photos on the right are really there just to show you the stark difference that we've seen in cover, and that we are making these gains in vegetation cover at the lagoon. It's just been relatively slower than maybe anticipated. Okay, so pivoting now to vegetation cover. So the figure on the left shows vegetation cover of salt marsh habitat from 2012 to 2022, with the dotted line or the dashed line at 85% representing the target that is set by the reference wetlands at around 85%. And you can see that we've been seeing this increase in vegetation cover over the 11-year period, but we're still falling short of that target set by the reference wetlands and are well below that 85%. And so if we look at salt marsh acreage broken down by cover class or vegetation cover, we see some interesting patterns. So on the left here, we're showing the acreage of salt marsh habitat with greater than 85% cover. And this is an area that we've seen actually pretty substantial gains in acreage, having gained 35 acres over the 11-year period. Whereas the figure in the middle shows salt marsh acreage that's between 60 and less than 85% cover, where we've gained around 14 acres. Despite both of these classes of cover starting at similar initial acreages in 2012. And then the cover class for 30 to less than 60% has only gained 8 acres over the 11-year period. And then the photos on the bottom really just to show many of you in the room, especially are local to the community. And so you're probably familiar with this, but there's a lot of variability in the vegetation that we see at San Dieguito, with more sparse cover shown on the left and higher marsh cover shown on the right within the same exact module at San Dieguito being W416, which for those of you that might be familiar, this is the part of San Dieguito Wetlands that is overlooked by the bird overlook over at the lagoon. And so while we evaluate both vegetation cover and habitat areas wetland wide, it can be useful for us to look at the patterns at these module by module scales to evaluate areas that are persistently have low cover versus areas that we see this incremental increase in vegetation cover over time. And so the next few slides are going to walk through some of those patterns at W23, which is just west of the I-5 freeway across from the boardwalk at the 22nd Agricultural District, and W416, which is on the eastern side of the freeway, which where I was showing previously. Oh gosh, this is a little challenging. I'm really forcing it, near the birdwing area over there. Okay, so starting first with W23. So here's our aerial imagery that is showing 2021 on the bottom and 2022 on the top. And each of those 10 by 10 meter grids that we were talking about is color coded by one of three habitats, either mudflat in brown, other in gray, or salt marsh in green. And so what we see is when you compare these 2 years, we've just circled one example of increased cover in salt marsh, where we see the conversion of other in gray to salt marsh in green. But we also see some areas of decreased cover in salt marsh with the loss of salt marsh and the conversion of that salt marsh to other. But if you look at these kind of really holistically and kind of blur your eyes, you see more green on top than you do in the bottom one. And so generally we see an increase in cover at this particular module. Moving now east to the freeway to W416, we're showing with these dotted circles areas in the northeastern and southern portions of the module where we've seen pretty substantial increases in cover in the conversion of both other and mudflat to salt marsh habitat. And so that's really promising. We also, though, are seeing increased cover in areas that were designed to be mudflat. And so to remind you, this is a map that Rachel showed in her talk that shows the planned areas for each of the three habitats. And those elevations are shown in the legend in case for reference. And so everywhere that you see that brown is where mudflat was planned to be. And and also that planned mudflat acreage was 24.9 acres. But again, like Rachel mentioned in her talk, we're at a 6.4 deficit in mudflat habitat as of 2022. And so a lot of this is driven by the encroachment of salt marsh plants into our planned mudflat habitat area. And so the photo on the right was actually taken one of the days that Rachel and I were out in the field, and we were well within the planned mudflat area, but you can see pretty dense stands of Spartina in the background and little shoots of Spartina making their way out into the mudflat. And so given this trend, we were interested in answering the question, how many mudflat acres have been lost due to salt marsh encroachment? And so the next few slides are going to focus really only on that planned mudflat area that I showed on the previous slide. So what we're showing here, focusing first on the figure on the left, is we've indicated the module areas with these dotted lines, and then only showing data from our planned mudflat areas. And again, these are color coded the same as the previous slides where we have mudflat in brown, other in gray, and salt marsh in green. And the border of this planned mudflat area is really dictated by elevation. So the planned mudflat habitat within San Dieguito ranges in elevation from -0.9 to 1.3 feet NGVD. And so that's what you're looking at here, is what that habitat area is at the lagoon. And the patterns are pretty stark. So looking at the figure on the left, you see that majority of the mudflat habitat in 2012 is mudflat, versus in 2022, shown on the right, you see that much of that planned mudflat habitat is salt marsh. And so much of this salt marsh that we see moving into the mudflat habitat is Spartina foliosa or cordgrass, which is, important habitat for a lot of species, but still is occurring in an area it was not designed to be. And so next I'm going to show you guys a series of figures that we're going to build out in a second, where we have the acres within that planned mudflat habitat that are either salt marsh on the left, mudflat in the middle, or other on the far right. And so what we see is that salt marsh has increased within this planned mudflat area from about 0.8 acres in 2012 to 9.7 acres in 2022. And that has led to a concurrent loss of mudflat from 20.3 acres in 2012 to 13.7 acres in 2022. And the 2.3 acre decline in other habitat translates directly into the conversion to salt marsh. And so that decrease in other is contributing to that 9.7 acres of salt marsh. And so taken all together, we see that approximately 40% of our planned mudflat habitat in 2012 has been converted to salt marsh by 2022. And so to investigate the potential drivers of this mudflat loss, we've been conducting these elevation surveys to evaluate potential topographic changes, which is just a fancy word for saying changes in elevation that might have facilitated this habitat transition from mudflat to vegetated salt marsh. And so this is showing the 1.3 contour in blue, which again is the planned lower limit of salt marsh vegetation and the upper limit of mudflat habitat. And so theoretically, if you think back to a couple slides ago, everything in that blue polygon that you see should be brown. But this is imagery from 2022, and you can see that a lot of that is now vegetated salt marsh. And so we're going to focus in on this mudflat habitat here just for the sake of time, but we have surveyed all the mudflats within San Dieguito this past year. And so how these surveys were designed is we would go into the marsh, the vegetation immediately bordering the mudflat, and we would take about 3 points using an instrument called an RTK that just collects the elevation of whatever the surface you're on is. And so we would go and we'd collect 1 point, collect another point, and we'd move into the interior of the mudflat until we reached around 10, 15 points in total. And then for the purposes of this talk, we've categorized those points as either being above or below that 1.3 foot contour, 1.3 foot elevation. And so points that are purple represent elevations that are less than 1.3, and points that are yellow represent points that are at or greater than 1.3 feet NGVD. And so you can see that most of the points that we surveyed within this mudflat are above that 1.3 foot NGVD. And as a reminder, everything within this blue polygon should be 1.3 or less, because that is what they were built to be. And so what this suggests, given that plants, the lower plan limit for elevation of these plants was 1.3, this suggests that these salt marsh plants can move much further into the mudflat than we currently see them. And so this may be a problem that could worsen in upcoming years. And I also want to mention that we've talked a lot about Spartina being the dominant species moving into the mudflat, but we also see other species like Salicornia pacifica or pickleweed and Jaumea carnosa occurring in these really dense patches throughout the mudflat as well. So it's not just Spartina. And so to review, we've seen this increase in salt marsh acreage at the wetlands since monitoring began, which is really promising because now we're only 1 acre short of meeting the minimum required acres. And this is driven in part by the conversion of other habitat to salt marsh. But that increase in salt marsh has also come at the cost of mudflat because many of those salt marsh plants are moving into the areas of planned mudflat. And then again, this photo on the right just shows patches of salt marsh plants well within that mudflat area. And so, yeah, so that is the situation here. All right, and so given these results, we're conducting these follow-up studies to evaluate potential topographic changes at multiple spatial scales and habitats to supplement the existing surveys that we conducted last year. And so in 2023, we're going to be conducting additional elevation surveys using RTKs. We have ordered a digital elevation model of the wetland and have ordered additional contours for 2023. And then since majority of the salt marsh that we see encroaching into the mudflat is indeed Spartina foliosa or cordgrass, we're going to continue to study the relationship between elevation and Spartina in San Dieguito relative to other wetlands in the region. And then with respect to future directions and next steps, we are currently consulting with a geomorphologist to explore the potential mechanisms driving these patterns. And what I didn't mention is that this salt marsh encroachment into these areas that were not planned to support salt marsh is not restricted to mudflat. We also see salt marsh moving into our tidal creeks, whereas Rachel mentioned during her talk is where we evaluate our invertebrate and fish standards. And so this is becoming something we're going to have to grapple with in the coming years. And so while my talk has focused exclusively on vegetation cover and the habitat area standard and the potential role of these topographic changes on the underperformance of these standards, Dr. Mark Page will provide a talk coming up next on the fish and invertebrate standards and their underperformance and the role of topography there. So.
Well, this presentation concerns the status of invertebrates and fish in San Dieguito Wetlands. And this slide just reviews the relative standard for invertebrates. And this standard requires that the total densities and numbers of species of macroinvertebrates shall be similar to the densities and number of species in similar habitats in the reference wetlands. This standard is evaluated separately for main channel and tidal creek, and as discussed by Rachel in the performance talk, the standards for density of macroinvertebrates has consistently underperformed in San Dieguito wetlands in both main channel and tidal creeks. Taking a look at the performance standard for fish, it's basically the same as for invertebrates. That is, it requires that the total densities and numbers of species of fish shall be similar in San Dieguito to the density and number of species in the reference sites. This standard has been met more consistently in San Dieguito wetlands, but the wetland unfortunately has failed this standard for fish density in tidal creeks and richness in main channel the past 3 years. So in this talk, we'd like to review some of the data that we've been collecting to address, understand and hopefully address the underperformance of invertebrates and fish in San Dieguito wetlands. So over the past year, we've evaluated 2 hypotheses to address the issues. The first is the sediment properties hypothesis. And this hypothesis proposes that some characteristics of the sediments is contributing to invertebrate, in particular, underperformance. So sediment properties, for example, the percent silt clay or the amount of organic matter has been shown to influence invertebrate distribution and abundance in some wetlands. However, we've taken a number of sediment samples and found that there are basically no differences. They're similar across all our wetlands. So today we're going to focus on the second hypothesis, which is the topography hypothesis. And this hypothesis proposes that some aspect or aspects of the physical structure of the wetland, for example, the elevation, is contributing to the underperformance of invertebrates and fish. So we were reported before, actually last year, that the tidal creeks in San Dieguito tend to be at a higher elevation than those in the reference wetlands. And in this figure, basically, we have, which one is it here? Here we go. We have the elevation of the thalweg on the y-axis. So the thalweg is the lowest elevation point in the tidal creek. On the x-axis, we have elevation. So we have San Dieguito indicated by the green symbol, and the 3 reference wetlands, Tijuana Estuary, Magoo Lagoon, and Carpentry Salt Marsh indicated by the black circles. And you can see that the elevation, the mean elevation of the thalweg in San Dieguito is about 7/10 of a foot higher than it is in the nearest reference site in terms of elevation, which is Tijuana, and about 1.3 to 1.8 feet higher than Carpentry or Magoo. So one consequences of this higher elevation of the tidal creeks in San Dieguito is that they're being inundated by tidal waters less frequently than those in the reference sites. So we've also collected data and looked at the relationship between invertebrate density and elevation and found a trend of decreasing invertebrate density with increase in elevation. So in this figure, we have invertebrate density on the y-axis. And we have wetland on the x-axis.
You advance.
There you go.
There we go. For San Dieguito, which are the green symbols, and the reference sites, Magoo, Carpentry, and Tijuana, indicated by the open symbols. And so we have begun to evaluate this topography hypothesis. And we've been very fortunate in that right across the river channel from San Dieguito Wetlands modules 2 and 3, we have the 22nd Ag District restoration, which has tidal creeks that are lower elevation than those in San Dieguito. So in this image, you can clearly see the ag district creeks. And then right across the river channel, you have the creeks in W2, W3, and the ag district creeks are full of water. And those in San Dieguito, in the San Dieguito module, are essentially dry at this point. So in addition to our typical performance monitoring that we do each year, we also did supplemental sampling in these deeper ag district creeks. And this slide just shows the location of the sampling that we did in the ag district, indicated by the yellow arrows. And there are 3 of these supplemental lower elevation tidal creeks that we sampled. And then we compared data from there from those sites to the higher elevation creeks that we typically monitor during performance monitoring. And the figure on the left just compares the mean elevation of the Thalweg, again, the lowest elevation point in the tidal creeks. And you can see that the lowest elevation, the mean Thalweg elevation is over about 1.5 feet lower in the ag district creeks compared to the creeks that we typically monitor in modules W2, W3. We were also able to take advantage of a couple of drainages that are acting as tidal creeks that are at lower elevations located on the east side of the freeway in modules W4, W16. And you can see the location of those in this photo on the left. Basically, again, the white arrows are showing the location of the 3 of our 6 creeks that we currently monitor. And then in the blow up, you can see the 2 lower elevation creeks that we also sampled at the same time. And the figure on the right then is comparing, again, the mean elevation of the Thalweg between these lower elevation creeks, supplemental creeks that we sampled, and the higher elevation creeks that we typically monitor during performance monitoring. So we combined the data, the 5 creeks that we sampled that were of lower elevation, and compared those data in terms of invertebrates and fish to the data from our 6 the creeks that we currently use in performance monitoring. And this figure shows the data that we have for, and we're able to compare invertebrate densities between these deeper, the lower elevation creeks and the currently monitored creeks. And you can see that the density of invertebrates is much greater in these lower elevation creeks that we sampled compared to the densities that we find at these higher elevation creeks that we sample during performance monitoring. Taking a look at species richness in the lower left, we see a similar pattern. That species richness is higher in these lower elevation creeks that we sampled in comparison to the creeks that we sampled during performance monitoring. Turning to fish. Sounds like a broken record, but we see basically the same pattern. We find higher densities of fish in these lower elevation creeks that we sampled in the ag district and the supplemental creeks in W4, W16 in comparison to the creeks that we sampled during performance monitoring. In the lower left, taking a look at species richness, we see a similar pattern. Higher species richness, greater species richness in these supplemental lower elevation creeks in comparison to the higher elevation creeks. So to summarize then, the standards for invertebrate and fish density and species richness in the tidal creeks of San Dieguito have not been met consistently. The tidal creeks in San Dieguito do not extend as low as the reference wetlands. The high elevation of the constructed tidal creeks in San Dieguito likely impedes the ability of the restoration site to consistently meet the relative standards for invertebrates and fish. And finally, measurements of wetland elevation are critical for identifying a possible reason that San Dieguito has not consistently met the relative standards for invertebrates and fish. So moving forward, future directions. We plan to continue our on-the-ground surveys that were touched on by Kat. And we're also obtaining a wetland-wide digital elevation model, or DEM, that will facilitate a geomorphological analysis to understand sediment inputs and processes, for example, erosion and accretion, It may be altering the topography of the wetland, for example, and also a habitat evolution model analysis to determine the aerial extent and rate of habitat conversion over time. And the issues that I've been talking about here are very much related to those that were just talked about by Kat. And the results of these studies will hopefully inform any future remedial action that may be necessary regarding tidal creeks, if it's needed. So that concludes this presentation. What we can do now is open it up to questions, comments, discussion, and begin with folks in the audience here in person, and then move to those that are virtually connected. So. Yeah.
Mark,
Yeah.
You focused on the tidal creeks,
Yeah.
but you also didn't meet the performance standards on the main channel.
Right. Yeah, that's right.
You have a response to that?
It's short. We don't really, we don't know. I mean, the sediment properties do not seem that different across the main channel sites either. And they're about at the same elevation. The thing that's different about San Dieguito in comparison to reference sites is that some of that, I guess it's 5 or 6 sites are not main channel sites, are not really in main channel per se, because San Dieguito doesn't really have main channels like as we see in the reference wetlands. So we haven't really been able to establish that could be the reason for the difference, but we're not, we need to explore that further.
in the tidal basin.
Yeah, they're in the tidal basin, basically. Yeah, exactly. And so we don't really know yet. I guess that's the bottom line. Play it safe.
Thanks.
But it's of interest to us for sure.
I seem to remember a few years ago, you shaved 2 inches off WT3, you had a wetter on there, did that work?
Right, so that kind of relates to cats or the previous 2 presentations where the vegetation is increasing the tidal inundation definitely helped for sure. And so it did help with the vegetation, but the problem could be that the tidal creeks were constructed too shallow as far as the performance standards for invertebrates and fish.
Yeah.
That's likely, I mean, I'm saying it likely impedes meeting the performance standard. So to meeting those performance standards.
Yeah, it was 2014.
Yeah, that's right. Yeah, that there's no question because it was graded fairly flat and high. And so there was an accumulation of salts, you'd be covered by a very high tide, the water would evaporate, it would be quite, salty. You could just see the salt crust basically. And grading it lower and also increasing the tidal creek drainage network in there definitely helps for sure. Alleviate some of those soil stress. Yeah.
So to my knowledge, San Dieguito is it extends further inland than the other reference wetlands. Have you looked at like the effective distance from the estuary mouth that any of your stations are?
Yeah, that's interesting. Yes. That's been one of the things that we looked at. So I had 2 hypotheses up here, but actually we can come up with other ones. That's one of them. And we didn't see relative to the reference wetlands that made much of a difference. Yeah. But you're right, it extends quite a ways in there, inland. Yeah.
I had a question about the supplemental sites that you measured at the ag district.
Yeah.
Those were deeper.
Yeah.
Would those have met the comparison in density or just?
Yes, those sites would have. But remember, it's a little complicated because the way we evaluate it is a 4-year running average. And so if you look at it for those sites compared to the ones across the river channel, yes.
On
Yeah, for that year.
Yeah.
Yeah, we can't because we just did it one time, but that's a very important question.
Do you all do any monitoring of the seagrass in subtidal area there?
No, see, it was not we don't. I know that's a particular interest for Kat. We've worked on the grass. But it's not really present in our reference sites that much. It's not present really a little, just very little bit, maybe Carpinteria. And I don't know, Magoo, not so much, and Tijuana, not so much. So it's not really in our reference sites.
But we do exotic species surveys within the basin. And during those surveys, our divers do collect percent cover data. So we do have that, but we don't have anything like shoot density or things that a lot of people would want if they wanted to look at eelgrass. Yeah.
Yeah, it's just the way, yeah, you're right. It's an important habitat, but it's not being monitored as part of this project because we can't find it in our reference sites.
Oh, yeah, I'm not just a resident of the area. I don't have any particular expertise in that field, but just here in general.
Oh, great. Well, thanks for coming.
I live pretty close to Los Penasquitos Marsh. And what I've noticed over time is that the outflow of the marsh gets blocked periodically.
Right.
Is that playing any sort of role in what you're seeing?
So that's a good question. One of the requirements that Edison has to fulfill is maintain the inlet in an open condition. So the requirement is for tidally influenced wetland. And therefore it's been getting dredged about every year at this point.
Every other year.
Every other year? Yeah, it's gotta be, and if it were to fill in, for instance, we'd probably hustle out there, or you guys would hustle out there and dredge it. So that probably is not the case at this point.
Yeah.
Well, I'm just wondering if that would affect the density of invertebrate
Oh, yeah.
species, right?
It's what I would say it could if it were plugged up.
Yeah.
But it's required to keep it open.
Yeah,
Yeah.
not only open, but we do tidal prison measurements, so
Yeah.
tidal flushing, and there has been. Because of this constant inlet maintenance, there has been no change in tidal flushing since 2011, so. yeah.
But that's a very good question.
Well, perhaps I have a little more cynical point of view on it, and I just noticed that one particular marsh gets blocked for extended periods of time.
Yeah.
Even though there was a requirement to keep it open, that to
Well,
my mind doesn't happen.
It's not a cynical question, it's a good question, because if you have a blocked inlet, it affects water quality. The DO that Rachel was talking about drops precipitously. And you can have die-offs of fish and invertebrates, so it's important to keep the inlet open, at least in our restoration project.
And I guess the follow-up question was because of the topography and in our particular area, it's the highway and the sort of channeling of the outlet in one particular area, it's sort of doomed to get blocked over and over again.
Right.
Is there a similar problem at the outlet of this San Dieguito? I mean, it's doomed
No,
to
this
get
is
blocked
like-
over and over again?
This is a great question for maybe Dr. Wine here,
Yeah.
who's a coastal process.
Yeah.
Yeah.
Yeah,
He's a coastal process guy from
Yeah,
Scripps.
so- We're asking how the inlet is designed and how we design the inlet, the potential of the inlet to get blocked. And how we designed it to continue to flush. Does it have potential to get blocked? So
Right,
can you explain
I
that
think,
to them?
the main answer to your question, really you have to understand the height of the segmentation of these areas. These small areas, and it's hard to keep themselves open. So they require monitoring for them to determine whether it's going to grow. But you have to understand the segmentation and when this sediment will fall, right? So the sediment will fall when the tidal basin becomes low. And the tidal basin becomes low for many reasons. Right? One of the reasons, the waves throw sand slide the inlet channel, right? If the sand go a little bit in the tidal basin or something, not further away, the lagoon is capable of driving it out. But if it's put it in the inlet, it will close it. So what you see in this inlet, and then what we watch all the time, the inlet channel between the shoreline and the highway 101, we watch the bottom of the channel. And if the bottom of the channel does not get elevated, right, we are fine. We know the lagoon is going fine. So we cleaned the east of the highway 101, such that the lagoon will have a good tidal basin, right? And that doesn't happen for most of the lagoons. You see them closing frequently. So we clear that, we ensure the lagoon have high tidal basin. In the same time, we watch the elevation of the inlet, what we call it the inlet, not the inlet channel. The inlet channel is very large, huge. the inlet itself. If the elevation of the inlet itself means the shoreline, get elevated, we get worried, right? So you have to really understand the process. What are people doing? They go and they dredge what we call is the area, here, but they never done anything. That's what they pay, right? And I don't think again, you have to understand this. That's why we keep this lagoon open all the time with minimum maintenance. The lagoon needs maintenance. So when we designed this lagoon, we saw that it would close within a year. Then we find where the lagoon is doing better. Now we are every 2 years. We can stay for 3 years, but that's going to be too much because the internal of the lagoon is going to be changes. And whatever we're going to do later inside the inlet itself is not going to help us. The waves will close it for you. I hope that's clear.
I think so. Mark, thanks, really great presentation, you guys. So this is kind of ironic for me because, you know, working on this project for 2006. And so in some cases, nature's funny, right? Because, you know, you say we develop the biomimicry, you're looking for this to basically become its own habitat and ecosystem. You're saying basically to the wetlands, okay, we need this much mud flats, we need this much salt marsh, we need this much this, blah, blah, blah. And what's interesting is that for whatever reason, maybe because the elevation being a little bit higher than expected for these channels, what we're really doing is attracting biomimicry and the salt marsh to move into that area. So in some cases, in some places, people would say, wow, that's really successful, right? You know, you're getting this salt marsh, but in our case, it's not because we're trying to maintain a certain amount of mud flat within that area, right? That acreage, which is so rare, right? This mud flat habitat. So do we think that if we did make some alterations in terms of that elevation of these channels, that we would prohibit or maybe reverse the salt marsh that's moving into these areas?
I think we need to improve our understanding, as we discussed, about the processes that are going on in terms of accretion and erosion and the direction things are going. It seems to us that it is very likely that the elevation of the creeks is influencing invertebrates and fish. The mud flat, you can think about how complicated that could be to remediate. So I think maybe next year we might have more information on that.
Yeah.
Hopefully the modeling that the hydrologist or the geomorphologist will do will answer whether or not those options would even be sustainable. And what is sustainable? Is sustainable 3 years, is it 10 years, is it 50 years? Because those are important answers before making any sort of recommendation.
We are not geomorphologists, so we retain some help on that.
Yeah.
I mean, just beyond really kind of going in and bulldozing down and starting to restart again with a lower elevation. There's not much you could really do without really, impacting.
You would need to know whether that
right?
mud flat is sustainable.
Yeah.
Given its current
Yeah,
location.
along with that last, and you're just destroying habitat, and it's gonna, go back to the way it was. So that's one of the key points in trying to understanding the dynamics of the process, which is why we're getting people that know what they're doing. Yeah,
What's the learning?
yeah.
So have you considered the fact that this actually might be beneficial mitigation for sea level rise?
Right. Getting all the hot topics. Sea level rise was actually not incorporated. This design for this project was quite a while ago, and people really weren't thinking too much back then about sea level rise. I think that's incorporated more now. In fact, I think incorporated in the Coastal Commission may require it.
Yeah, they do.
But in this project, it was not part of the design. And so, yes, 30 years from now. But I think we're trying to deal with it right now. We can't really anticipate what it might look like in 20 or 30 years, but we agree that could be helpful down the line. Yeah.
I was gonna ask questions along these lines too, but I was curious about the elevation you're seeing accumulated in the mud flats. Are you comparing that to the asphalt, or so there is an accumulation?
Yeah.
Have you thought about, because is it that there's deposition, or could it be that it's happening because the plants are coming in and they're dropping organic material as
That's a great.
marshes are supposed to do to keep level with sea level
Especially
rise?
part-time,
Probably both.
Yeah, and unfortunately, we don't have any elevation data before the Spartina moved in or as the Spartina was moving in to be able to answer that. But we're hoping that these repeat digital elevation models will somewhat get at that and help us evaluate whether or not there's been accretion. And you can do things like feldspar that we're talking about doing and things like that to measure accretion rates inside versus outside of Spartina patches within the mudflat. So we're exploring all those options.
You can also go on Google Earth. It's pretty interesting to go
Yeah.
back in time on Google Earth and then look at these mudflats and you can see this sedimentary delta sort of moving kind of into the mudflat.
Yeah.
And then the Spartina is coming into those areas.
Yeah.
You can see it on Google Earth.
Yeah.
And I also kind of was wondering about, I mean, because I remember when this began, we didn't think about sea level rise. We didn't talk about, we didn't say the words climate change.
Yeah,
And
right.
so it is kind of, I don't know. I don't know if you can consider that now.
That would be a policy decision.
Dynamic model, like.
Where's Alexis?
Yeah.
Is she here?
Yeah.
I don't know. Yes,
Do you plan to keep sampling your supplemental tidal creeks that are deeper? They're still in the marsh and.
yeah, we haven't talked about that. That was done last year when we were doing our performance monitoring. That's something that we can discuss doing. The differences are quite dramatic though, in terms of invertebrate density between the lower elevation creeks.
And those were done more recently, weren't they?
And those were done about 7 years ago or so.
Yeah,
Not that recent.
2016.
Not,
Oh,
Yeah.
like an ad, yeah.
yeah, not that recent, but within, 7 years or so.
They may change too, for all we know.
Right.
Yeah,
Yeah, I was just gonna say with that, yeah, you have to monitor the Spartina because it is moving in channels
Yeah.
more so, both in the ag district and in our wetlands. So you sort of have the elevation issue and then the Spartina is a separate issue.
oh,
And, if you just look, especially like the ag 1 year, you might not see the change going forward from the Spartina increase. That was just out there.
well, it's something we can talk among ourselves about whether we should do it another year.
Yeah.
Sort of a legitimate conversation.
I have one other question. You said you were gonna look also at what the elevation of cordgrass is in other systems, and I don't know if those are local systems or those are the local systems?
Yeah, we've begun to do that. Done some surveys in Tijuana estuary too, and then also in the restored creeks of San Dieguito to compare creeks with and without.
So one thing I was kind of thinking about, I don't know if you can measure it, but it may be elevation, but it's, it's likely inundation, and so the elevation may, even there's a relationship, it may be different in different places because of the tidal prism or if there's a lag. So are you able to somehow figure out the actual inundation
Right.
in those areas?
We, not in those specific areas, but we have inundation curves from 3 reference wetlands and San Dieguito at one location, I guess. And we're collecting data now that we can do that for more spots in San Dieguito. They're about the same, except for Tijuana, which seems to spend the lower elevation spend more time underwater than San Dieguito or the other reference sites.
And the tidal creek morphology of Tijuana is so different than San Dieguito. Our creeks are much shallower and gradual along the banks, whereas Tijuana is a steep bank edge where you have vegetation and then it's a big drop. And so the Spartina couldn't physically exist lower. And so that also is why we don't see the same patterns, is because the actual geomorphology of the creeks themselves is very different. But Rachel did like a literature review of Spartina from Alamitos down to San Quintin, I think. And San Dieguito seems, at least at first glance, to be a little bit more unique and have a wider range of elevations that Spartina can exist in. But we have to dig a little deeper into that. Yeah.
More questions from the audience? Yeah.
Have you thought about doing almost the inverse of what you did, like in one of the reference or in the reference wetlands, looking for tidal creeks and main channels that look like San Dieguito's more, so that you could see in an established wetland what it looks like at those elevations? Because if that is the design elevation, right, like the proposed habitat showed, but I think that maybe the main creek, right?
It would be great to be able to do that, but in all our reference sites, they're all deep, lower elevation.
And
We
if
don't
you
have that
wanted,
range.
yeah, and if you wanted to get shallower, you would need to go so far into the creeks that now you'd be confounded by distance from main channel, and there'd be a lot of other issues you have to contend with.
Yeah, but
So that's a problem
that would have
also.
been a nice comparison, but we can't. do that.
Yeah.
Along those lines, I was kind of wondering about, like, historically, the systems may not have, and when I say historically, I mean, like looking at the T sheets from 1800s, they may not have been similar systems, you know, like San Dieguito was probably more like San Alejo or Penasquitos, and obviously we modified Aguadillo, that kind of good stuff, but I guess is it really a fair comparison? Like Tijuana is this big valley, and San Dieguito is a valley, but it's not like Tijuana, so I'm not saying I'm not throwing out a solution, I'm just saying it's like.
Well, no, of course, we, as was pointed out by Rachel, we evaluated 40+ wetlands in terms of meeting the criteria that's in the permit to qualify as a reference site. So what you're saying, what you're talking about could be the case, but we're going by what's in the permit, and our, when it gets right down to it, our choices are pretty limited. Yeah, somebody.
I was just gonna say, I don't know if you guys are still on Zoom, if people on Zoom have any questions.
Oh, I think so.
Yeah, we do have some questions on Zoom.
Did you have a question though?
Oh, yeah, then, what are the standards that you put like the fish and vertebrate, vegetation and, like, things like that, compared to, like, make them, or seem that they're healthy versus, like, or healthy versus, like, not healthy, or what are the standards that you compare them to?
So all of those standards are compared.
Can you repeat that?
Yeah.
The microphone didn't take up.
Sure, so the question was, how do we evaluate whether or not standards like inverts and fish and vegetation cover are healthy or not? And so we don't really use healthy or not, but we use similar to or dissimilar to. And so we would compare invertebrate densities or vegetation cover at San Dieguito relative to the 3 reference wetlands. And if San Dieguito is similar to the lowest performing reference wetland for any given standard, it would be considered to be similar enough and that standard would be met. So that's how they're evaluated. Yeah. Not better or worse, just similar. Because you don't want to require, the point of the permit and the point of evaluating it is not to require the wetland to outperform the references, but to be similar to. Yeah,
The assumption there is that the reference.
yeah, right.
Maybe we can take one more and then go to Zoom.
Have you been able to measure sediment input pre and post from upstream development into the wetlands?
Great question.
That's a great question, but we have not measured sediment delivery into the wetland or accretion or erosion. We'll maybe have a little bit of a handle on that after this analysis, the geomorphological analysis, and evaluating some of the elevation data that we've been collecting, because we're doing it over time. And also we'll have this DEM, which we plan to do over time. So we might be getting information on that in the future, but we don't have it at the moment.
Yeah.
But it's a good question, because that really goes to the heart of the topography hypothesis. Maybe we should move on, take some questions from a virtual audience.
Yeah, I have a question from Oliver Ryder. Oliver, I'm gonna allow you to unmute yourself.
Hi, well, thanks for the opportunity. My question, there's been some discussion relevant to it in the last 10 minutes or so since I wrote it. But the tidal creeks were built according to the specifications in the construction, and they are lower than for the reference wetlands. Was the impact of these differences anticipated? And how might this information inform the wetland restoration construction now taking place to the east of the Songs project?
So I think that the tidal creeks were built, the as-built, they were built, but they were, the as-built is at a higher elevation than the elevation of the tidal creeks in the reference wetlands.
Yeah.
Yeah, the elevation of the tidal creeks in San Dieguito are at a higher elevation than those in the reference wetlands that we monitor. Yeah, so it's kind of backwards, but what was the other part, the other half?
Oh, W19, whether or not.
Oh, I would think potentially, if you're looking to get, invertebrates and fish and abundance that you would expect in a reference site, you might want to make sure that the elevation is appropriate.
Not to put Sue on the spot, but we have someone from that project here.
Yeah, I know. So do you want to comment on that?
Do you want to comment on the design of the creeks?
Well, we were focusing on the reference when we designed them, but our tidal creeks are designed to be wet, they're deeper and wetter all the time, so. We also have a lot of drainages coming in, so we don't know what will happen over time. They could make them more open, or they could bring in sediment as well, so. We have a lot of offsite drainage coming through the site, so.
So I guess the answer is yes.
Thank you.
I have a question from Josie McKinley. Josie, start your, you could mute.
Hello, I have a question that may have been answered, but kind of hard to hear sometimes. I was just wondering, are you finding similar mudflat loss to marsh due to Spartina on your reference sites?
Spartina is only present in Tijuana estuary. There's a little bit in Magoo Lagoon, but it's most abundant in Tijuana. And we're not. Spartina is a performance standard, but it relates more to the height of the Spartina and its suitability as a nesting habitat for the Ridgway's rail. And we haven't been explicitly measuring changes in Spartina distribution in Tijuana.
She was saying mudflat.
Oh, mudflat.
Are we seeing similar patterns of mudflat loss in the reference sites?
Oh, and the answer to that is no.
Yeah.
Not within the area that we monitor for our project, but Jeff Crooks, who works and leads a lot of the work at the reserve there, has noticed Spartina moving into some of their mudflats, but that's not within the area that we monitor, which is not restored natural wetland. And so at least for the natural undisturbed part of Tijuana, we don't see the same pattern that we see at San Dieguito.
And you don't see any diminution of mudflat and carp or lagoon.
Yeah. Is that?
Yes, that answers my question. Thank you.
Sorry.
I don't have any more questions from.
Okay, well, we can take more questions from the audience and hear if anybody has any. Yeah.
I had one more about some of the stuff Rachel was talking about with the monitoring metrics. So I'm really excited about birds. Because I like birds. And I was curious because I understand that birds like marshes for food. So I was wondering if you saw over the years any correlation between like fish and invertebrate density with bird visitation.
Can you repeat that question?
Basically, is there a correlation between bird visitation and fish and invertebrate density?
Oh, yeah, the microphone's not picking it up.
Oh, yeah.
Just for the webinar.
Yeah, go see.
Yeah.
Is there a correlation between invertebrate density and fish habitat use / fish density or bird density? So is there more birds and more food, or less food and fewer birds kind of question?
Yeah, that's definitely something we need to look at more. It's kind of challenge.
I can comment on that in the sense that if you look at our data and the density of invertebrates, although they are in tidal creeks and main channel, not necessarily in mudflats where they might be, there was a decline over time actually in the densities of invertebrates and no change in bird feeding. So it's
pretty low.
yeah, it's hard to say, I guess. At this point, it doesn't look like there would be a strong relationship at this point. But then we're not monitoring necessarily where the birds are. It's more being in the flatlands.
Yeah, there might be a mismatch in like.
There might be a mismatch.
Where we monitor the inverts versus where. So it might be.
Yeah, of course, inverts are feeding in the tidal creeks too.
Yeah.
But the bird population has been really healthy and expanded.
It has the bird density, but it's it's beat out the lowest part of the site.
Yeah, it's the better.
Yeah. Any other questions?
One last
Yeah.
comment. I'm Jenny from Edison. I just wanted to say thank you. This is really great presentation and a really wonderful discussion. I wanted to add that I'm also grateful that we're only talking about mudflat. For those of you who've been in past talks, we're also been really worried about salt marsh. And so the last couple of years, Edison's put thousands and thousands of plants in, and with this rain, I think it's looking very favorable. We're going to continue to plant. We did one planting event earlier this year. We have another one planting this fall. And so we're going to continue to keep moving forward on the salt marsh and continue to support these investigations. And I just wanted to say thank you for all the really good thought that's going into looking at these issues and solving them. So,
Oh, thanks.
and I'm here if anybody has questions.
Yeah. Yeah, Edison's had a great, very aggressive planting program that's like we have.
209,000.
Yeah, 9,000 plants in the ground, so.
I know it's hard to say.
Any other questions? All right, well, thank you for your attendance.